Hello students, thanks for watching. So we are now going straight to the business, and that is the Fourier series. The first videos, they are actually trying to create help us to build a foundation upon which we are going to explain the concept of Fourier series. So the most important thing now is that if we have a periodic function f of x, and that function is defined in the interval of minus pi to pi. So we are looking for another group of expression to represent that periodic function. And that expression must only be sine and cosine. What am I trying to say is that, let's say for instance, we know a function f of x now. Don't forget the condition that f of x is periodic and it is defined in a particular interval. Here we're dealing with m from minus pi to pi. Okay, so we are looking for expression to represent the function, to represent the periodic function using only sine and cosine. Let's take for instance now, we have a function f of x, and that function is equal to a naught plus a1 cos 1x plus a2 cos 2x. We can continue like this to give us a3 cos 3x, a4 cos 4x, a5 cos 5x, like that. Then plus an cos nx. As n is increasing now, we are talking about infinite series. So, but that's not all. Plus b1 sine 1x plus b2 sine 2x plus bn sine nx. If it continues like that, then that is what we are looking for. This is what is called Fourier series. But mind you, that is not all. What of something like b naught? How come we don't have b naught? Do you notice that? I only call your attention to a naught, a1, a2, a3, a4, a5 up to an. And we have b1, b2, b3, b4, b5 up to bn. How come we don't have anything like b naught? Now, if we have b naught, remember that it's going to be b naught sine 0s. It's going to be b naught sine 0s. And what is sine 0? Sine 0 is what is 0. But what about cos? If we have a naught cos 0x, don't forget that cos 0 is what is 1. So that is the reason why in Fourier series we do not have anything like b naught. So without wasting much of our time, which means that this thing we are calling Fourier series, it can be represented as that expression we can see on the screen. If you look at this expression, you will see that the expression is saying that f of x, which is a periodic function, divided over the interval of minus pi to pi, it can be represented as a naught plus a series, and that series, it ranges from 1 to infinity. That is why you can see it in red color. Then plus an cos ns. Don't forget that this sequence here is talking about a1 cos 1s, a2 cos 2s, a3 cos 3s, a4 cos 4s. That means that we can represent that one as an cos nx. The same thing applicable to bn. We can have b1 sine 1x, b2 sine 2x, b3. So we have it like that. So, but there are some key points here. Number one, we should always remember that Fourier series is just a representation of a periodic function, as a sum of sine and cosine. Throughout this course, we shall be dealing with only cos and sine. Even we are going to have something like Fourier sine series, Fourier cosine series. Number two, it's just like a way to decompose a complex, a periodic signal into a simpler sinusoidal component. The Fourier series, it actually converges to the function f of x. At that point, where f of x is continuous. What about discontinuity? At a point of discontinuity, even the series, which is the Fourier series f of x, it converges to the average of the left hand and right hand limit of the function. And later on, we are still going to consider what is called the Dirichlet condition, which we explain this point to us. But mind you, we need to find a naught. We need an expression for a naught. We need an expression for an. We need an expression for bn. That is the next thing we're going to consider. Thank you for watching. Bye.